Get ready, space enthusiasts, because we're about to dive into the most mind-blowing cosmic spectacle ever witnessed. The James Webb Space Telescope, humanity's ultimate eye in the sky, just caught a colossal event on Neptune, the mysterious ice giant lurking at the edge of our solar system. This wasn't some routine storm or a flicker of clouds. It was a massive, game-changing collision that's flipping everything we thought we knew about the outer planets. Hit that like and subscribe button to stay locked into the universe's wildest updates, and let's unravel this epic cosmic drama. Neptune's always been the solar system's quiet enigma, wrapped in a deep blue haze of methane-rich clouds and whipped by winds faster than anything on Earth, sitting 30 times farther from the sun than we are. It's a world so remote that even our best telescopes struggle to pierce its secrets. While Jupiter and Saturn steal the spotlight with their bold stripes and iconic rings, Neptune's been out there in the dark, doing its thing, largely ignored, but not anymore. The JWST, a marvel of engineering designed to peer into the dawn of the universe, just stumbled onto something extraordinary while scanning Neptune's southern hemisphere. What it found wasn't just a blip, it was a cosmic haymaker. Picture this: JWST, with its golden mirror and unmatched infrared vision, was casually observing Neptune's cloud patterns and magnetic quirks during a routine deep space session. Suddenly, its sensors lit up with a massive spike in infrared radiation, a blazing signal completely out of character for Neptune's chilly, uniform glow. Alongside it, astronomers spotted a visual disturbance rippling across the planet's outermost clouds, too enormous to brush off as a storm. This was no ordinary weather event. The data screamed one thing loud and clear: something huge had just slammed into Neptune. What was it? Early analysis points to a rogue object, likely a 30 to 50 kilometer wide chunk of ice and rock, possibly a Kuiper Belt object that got knocked off course. This wasn't a gentle graze. The impactor hit with such force that it unleashed shockwaves through Neptune's atmosphere, tearing through its cloud bands and sending ripples across the planet's faint, delicate ring system. The energy released was staggering, turning a normally cool, dim region into one of the brightest thermal hotspots ever recorded on Neptune. For a planet that's been quietly spinning in the dark for billions of years, this was like a fireworks show in the middle of a silent night. The JWST didn't just catch the flash, it captured the aftermath in stunning detail. A hazy arc of debris, likely fragments of the impactor itself, lingered in Neptune's upper atmosphere for days, glowing in both infrared and visible light. Scientists suspect this object was a mix of volatile ices and rocky material, similar to the countless objects drifting in the Kuiper Belt just beyond Neptune's orbit. Maybe it was a rogue wanderer, nudged out of its path by a gravitational tug, only to meet its end in a fiery plunge into the ice giant. Whatever it was, it didn't go quietly. This collision wasn't just a surface-level show. Neptune's magnetic field, already one of the strangest in the solar system, tilted wildly off its rotational axis and, prone to chaotic swings, went haywire. JWST's instruments picked up a surge in charged particles, suggesting the impact sent shockwaves deep enough to mess with the planet's internal dynamo. Think about that. A single crash was powerful enough to rattle the very engine that powers Neptune's magnetic field. That's not just a dent, it's a planetary wake-up call. Why does this matter? For starters, it's a reminder that the outer solar system isn't the sleepy, static place we once thought. We've long assumed massive collisions like this were relics of the solar system's wild youth, when debris flew around like cosmic pinballs. But this event proves the Kuiper Belt and beyond is still buzzing with activity. There could be thousands, maybe millions, of rogue objects out there, just waiting for their moment to cause chaos. If something this big hit Earth, we'd be toast, no question. Neptune's giving us a rare chance to study what happens when a planet takes a hit of this magnitude. And the data's a goldmine. The impact's effects are still rippling through Neptune. Its jet streams, some of the fastest in the solar system, clocking in at over 1,500 miles per hour, seem to have been thrown off kilter. Scientists are spotting changes in cloud velocities and turbulence patterns, suggesting the collision might supercharged or deflected these winds. The planet's rings, usually so faint they're barely visible, flickered with unusual brightness in the days following the impact, likely from debris or micrometeorites kicked up by the shockwaves. Even Neptune's atmospheric chemistry is shifting, with spikes in hydrocarbons and nitrogen compounds that weren't there before. These could be remnants of the impactor or the result of deep atmospheric layers getting churned up by the heat and pressure of the crash. What makes this discovery even crazier is how it happened. The JWST wasn't even hunting for collisions. It was built to stare at distant galaxies and sniff out exoplanet atmospheres, not to play cosmic detective in our own backyard. Yet its infrared sensitivity was the perfect tool to catch this fleeting event. Ground-based telescopes, even the best ones, would have likely missed the rapid infrared flash, drowned out by Earth's atmosphere or light pollution. If JWST hadn't been looking at the right place at the right time, this whole event might have slipped away, lost in Neptune's churning blue haze. This fluke discovery is a wake-up call for astronomers. It's pushing scientists to rethink how we monitor the outer solar system. The fact that a 50-kilometer object can sneak up and slam into a planet without warning suggests we need better eyes on the Kuiper Belt and beyond. Current planetary defense strategies focus on near asteroids, but this event shows that the outer planets aren't immune to surprises either. Studying Neptune's collision gives us a playbook for what a massive impact looks like: energy transfer, shockwave propagation, atmospheric disruptions, all critical for understanding how to protect Earth if a rogue object ever comes our way. The scientific community is buzzing with excitement. Observatories in Chile and Hawaii are already tweaking their schedules to follow up on JWST's findings. The Hubble Space Telescope, while not as infrared savvy, is being tasked with capturing visual and ultraviolet data to complement the initial discovery. The European Southern Observatory is planning spectrographic scans during Neptune's next opposition, when it's perfectly positioned for Earth-based viewing. Every new observation adds another piece to the puzzle, helping us understand not just what happened, but what it means for Neptune and the rest of the solar system. Let's talk about Neptune's rings for a second. These aren't the bold, flashy hoops of Saturn, they're faint, wispy arcs that are tough to spot even with the best telescopes. But post-collision they lit up like never before. Scientists think the impact might have dislodged tiny particles, or added new debris to the ring system, temporarily boosting its brightness. Over time, this could subtly reshape the rings, maybe altering their density or structure. It's a rare chance to see how a planet's delicate features respond to a massive jolt, and researchers are eager to track any long-term changes. The chemical fallout is another big deal. Those new hydrocarbons and nitrogen compounds in Neptune's atmosphere are like fingerprints from the impact, or maybe clues to what's hiding deep inside the planet. The heat and pressure from the collision could have triggered reactions that pulled up material from Neptune's lower layers, giving us a peek at its hidden chemistry. This isn't just cool for Neptune fans, it's a window into the atmospheres of other ice giants, like Uranus, and even far-off exoplanets. If we can figure out how Neptune's atmosphere reacts to this kind of trauma, we might better understand the wild, extreme worlds circling distant stars. This event is also rewriting the story of our solar system's evolution. For years, scientists thought the outer planets had settled into a calm, predictable routine after billions of years of chaos. But this collision suggests the Kuiper Belt is still a dynamic place, with objects big enough to cause serious damage. It's like finding out the quiet neighbor at the end of the street is secretly hosting wild parties. The idea that Neptune, of all planets, could be a stage for such a dramatic event challenges our assumptions about the solar system's outer reaches. It's a reminder that even in the cold, dark void, things are still moving, colliding, and changing. For planetary scientists, this is a once-in-a-lifetime dataset. The impact's effects on Neptune's atmosphere, rings, and magnetic field offer a natural laboratory for studying processes we can't replicate on Earth. How does a gas giant's atmosphere absorb and redistribute that kind of energy? How do shockwaves interact with high-speed jet streams? What happens to a planet's magnetic field when it gets a cosmic punch? These are questions we couldn't answer without an event like this, and Neptune's delivering answers in real time. Broader implications are just as exciting. This collision is a test case for theories about how planets form and evolve. The outer solar system's history is tied to the migration of giant planets like Neptune, which scattered debris as they settled into their orbits. Finding a massive impact like this suggests that scattering might still be happening, just on a slower, subtler scale. It's a hint that the solar system isn't as settled as we thought, and that the dance of planets and debris is still ongoing.